Okay, so bell work, let me get my answer key here. For number 1, what you should have done is set this 2x plus 5 equal to positive 9 and 2x plus 5 equal to negative 9 to get the two solutions. And you would have gotten x equals 2 and x equals negative 7. And then you can plug that in to test it, and they both work. So the solutions are 2 and negative 7. Did you guys get that? Didn't? Do you want me to solve it out more? To get the 2, negative 5, I get 2x equals 4. Divide by 2, and that's how I get the x equals 2. Subtract 5, 2x equals negative 14, which then solves to x equals negative 7. Next, we would have solved that. What did you guys get for that one? Did you get x equals 2? Good job. Anybody not get x equals 2? Want me to go over the... Okay, I'll go over it. Let's see if I can find some space here. 12 plus 5x minus 8 equals 12x minus 10. So I just rewrote the original. 12 plus negative 8 would be 4, so 5x plus 4 equals 12x minus 10. Now I want to get everything on one side. Get the x's over here. Negative 7x equals negative 14. Divide both sides by negative 7, and I get x equals positive 2. So that's there. This here, 12 plus negative 8. So I combine the constants. Okay, the next one was the long one. Did anybody solve number 3 all the way through? Did you get negative 1 twice? Okay. I'm definitely going to go through number 3. That's like, honestly, it's like worst case scenario in this chapter. I think it's one of the harder problems that you'll come across. Before we do anything, we need to get the absolute value by itself. I'm going to rewrite the problem here, so that way I have room to solve it. So first step is to get the absolute value by itself. So I'm going to add 2x to both sides. And then the next step in getting this by itself, I need to divide by 3 on both sides. So divide this by 3, that cancels. Then I need to divide this side by 3. I get absolute value of 2x plus 2 is equal to x plus 1. Now I'm going to lightly circle this because this is what I'm going to plug in my solutions to test to make sure they're right. I could plug in my solutions into this guy or this one. They're both equal. This one's a little bit easier to work with. So now that I have this, I'm going to set this equal to positive x plus 1 and then equal to negative x plus 1. So I get 2x plus 2 equal to positive x plus 1 and 2x plus 2 equal to negative x plus negative 1. And then I'll solve from here. So I got x equals negative 1 on this side. X equals negative 3, divide both sides by 3, and I get x equals negative 1. So I got the same solution here, so when I go to check my solution, I only need to plug in negative 1. So now that I have these, I'm going to take this original right here and plug it in. 2 times negative 1 plus 2, absolute value symbol equals negative 1 plus 1. Solving this, negative 2 plus 2 is just 0. Absolute value of 0 is 0. And then negative 1 plus 1 is 0. So 0 does equal 0. So therefore, negative 1 is a solution to this equation. Okay. Next one. Next one asks you to name the set of numbers that 4 belongs to. This one you might have looked back at that chart. Let me see if I can get it. This chart of real numbers. And this one right here. This chart right here. So when I talk about 4, looking at this chart, I'm going to start with the top. It is a real number. 4 is a real number. Is it rational? Can it be represented as a fraction? Yes, it is. So it's also rational. Is it a positive or negative whole number? Yes, so it's also an integer. Is it a whole number? Is it 0 up to infinity? Yes, it is. So it's a whole number. And then natural is all the whole numbers minus 0. So it is also a natural number. And the most specific way to name 4 would be it is a natural number. Okay, so today we're working with inequalities, starting here. Inequalities, I'm sure you've heard of that word before. Inequalities are the expressions with the less than sign, greater than symbol, less than or equal to, or greater than or equal to. These are used in inequalities. Remember these? This lesson's actually pretty easy. So look at this chart. We're going to not only be solving inequalities, but also graphing them. Some things to remember. So this is an inequality. X is less than -5. When we graph this, if it doesn't have the line underneath, we're going to use an open dot. I could probably draw that a little bit better. Okay, so open dot if it doesn't have the line. This one doesn't have a line. We're going to use an open dot. This one does have the line under it, meaning x is less than or equal to 5, so it'll be a closed dot. And then again with the line under it, we're using a closed dot. Does this sound familiar? Okay. So to graph this, x is less than -5, I'm going to use an open dot on -5. And x is less than, so it's going to be all the numbers less than. So in saying this out loud like that, you can figure out which way the arrow goes. Another hack to make sure that it's in the right direction, something I've noticed, is if the variable is first, this inequality symbol will match the arrow. So that's a good way to check to make sure your arrow is going in the right direction. If the x, y, z is first, then this will match the arrow that's here. So that's a good way to check and make sure it's going in the right direction. So here it says x is now greater than 5, so we're going to do open dot on 5. X is greater than, so all the numbers greater than 5 would go this way. And then just make sure this inequality matches that. And then less than or equal to. X is less than or equal to 5. We're going to do a closed dot on 5. X is less than, so it's going to be all the numbers less than. Then x is greater than or equal to -5. Closed dot on -5. X is greater than, so it goes this way. And then just make sure that arrow is matching this arrow. Again, in order to use that hack, the variable has to be first. Okay, solving inequalities. When you solve these, it's just like solving an equation. So, for example, I'm going to make an example right here. 2x is less than 10. To solve this, you would just divide both sides by 2 to get x is less than 5. And then you would graph it. The only differences between inequalities and equations is if you're dividing by a negative number, you have to change the direction of the sign. So let's say you get -2x is less than 10. And in order to solve it, you have to divide by a negative number. Then all you do is you change the direction of the sign. So the sign is this way, now we're going to change it this way and get x is greater than -5. So if you divide or multiply by a negative number, you change the sign. And that's what this don't forget is. then you really don't come across this in the practice problems, but something to take note of. If the inequality solves to a true statement like 5 is less than 9, then all solutions will work for this inequality. If it solves in one direction, like the examples we're working with today, x is less than 4, then it'll be all the solutions in one direction. And then if it comes out to a false statement like 4 is less than 2, you have no solution. Not it. Who is it? I don't know. Who could it be? Hello. Are you a new student too?
Yeah.
Oh, I just got another new student. Let me see where I have an empty spot. Attendance, seating chart. Yep, you just showed up on my roster. Okay. Are you you're Katie?
Yeah.
Cool. Well, I don't have any more numbered seats. I'm running out of seats. And then your number will be 31. Or 5 on the first minute or 3 absent? I guess we'll find out. Okay. So you'll be 31, so you'll put your phone here until. Yeah, these two are just absent. And I thought I had an extra note packet. Did I give them all away? Trying to see if I had an extra note packet for you. No. Okay, so for today you can just watch us because I don't have an extra note packet for you. I'll have to print one out. Okay. Anyways, okay, over to the examples. So for these examples, all we're going to do is solve the inequality and then graph it on the line. So first step for this one, some of you may already be working ahead, just distribute that 2 to both of those. So we get 8x plus 2 plus 3 is greater than -3. And then we'll continue simplifying and solving. 8x plus 5 is greater than -3. Divide by 8. X equals -1. Oh, not equal. Greater than. Okay. Greater than or greater than -1. So when we graph it, we're going to use an open dot. And it doesn't have the labels on the graph, so you can kind of put them in. Open dot on -1. This would be 0, 1, -2 this way, -3. So you have an open dot on -1, and then x is greater than that, so we're going to do our arrow to all the numbers greater than -1. I feel like I had another copy. I don't know where it went. Okay, 11, same idea. Distribute the -4 to both of those terms. -4x plus 28 less than or equal to -20. Subtract 28 from both sides. Then we're going to divide both sides by -4. The way this is different from the previous one is we're dividing now by a negative number. So that is our red flag that we have to switch the sign in the other direction. So our symbol is now going to go like this. This becomes x, and -48 divided by -4 would be 12. So x is greater than or equal to 12. And then once we have that, we can graph. Because it has a line underneath, we're going to use a closed dot. This would be at 12. going to just number higher and then lower over here. As long as you're consistent in numbering, it doesn't really matter what you put there. Then x is greater than 12, so the arrow will go in this direction. And last but not least, well, we have two more examples. One, just like we've done before, and then one word problem example. So distributing the 3 to both of those terms, we get 6y minus 6 is less than 2y minus 30. And it should solve y is less than negative 6. On the number line, use an open dot for negative 6. And then y is less than that, so it would go this way on the number line. You can check and just make sure that arrow's in the right direction. As long as your variable is first, this arrow should match this symbol. And last but not least, we have a word problem here, a real life example. It says, Javier has at most $15 to spend today. Before I look at the rest of the problem and get overwhelmed or confused, I'm going to write that down. Javier cannot spend more than $15. So what he spends has to be less than or equal to 15. So just making a note. Then I'm going to start looking at the other numbers. He buys a bag of pretzels and a bottle of juice for $1.59. Boy, do I wish those prices were still accurate. Pretzels and a bottle of juice for $1.59. If gasoline at this store costs $2.89, I miss those days too, how many gallons of gas to the nearest tenth of a gallon can Javier buy for his car? Okay, so $1.59 plus $2.89 per gallon has to be less than or equal to the $15 he has. And then from here we can solve it to see how many gallons of gasoline he can actually buy. So I'm going to start by subtracting $1.59 from both sides. You could do it the old-fashioned way by hand or by a calculator. It comes out to $13.41. So you can spend $13.41 in gas. Are you kidding? Don't they understand I'm trying to teach you? Go ahead and solve that. Hola, ¿cómo estás? Hello, what's up? Okay, after we're done with lesson? Okay, thank you. So give me Miss Thomas, one for that. Where's that? Discipline? Okay. Can't be that bad, otherwise they'd come and get you, so you're good. Okay. Here we go, divide by 289 on both sides, and you get a weird decimal. It comes out to like 4.64013 and some more numbers. So once you get here, it says to round to the nearest tenth, which would be this first decimal place. So it would round to 4.6. So you need to buy less than or equal to 4.6. Do some of you drive already? Either with your permit or your license? Most of you probably at this point, yeah? Okay, and that's the answer. Any questions? Yes?
Let's have a question. Do you have to write greater than or less than symbol?
So If it was in the real world, yeah, you could just set it equal, and then you'd know that, you know, you can spend that much on gas. But because we're working with inequalities, you're going to be looking for inequality. Okay, that's it for today's lesson. It should be pretty easy. Your homework questions will look like this. Because all of the computers have a hard time logging on at the same time, I am going to have you use your phone for the homework. If you finish your homework early, then you should be, whoa, Julian, wait a second. If you finish your homework early, you should be going on to Khan Academy and getting that started for the week. I need to see that everybody's actually working on their homework on Schoology, because if I have like even 2 or 3 that are just playing games on their phone, then it's not worth using the phones, and we'll have to go to the laptops, which take a longer time to log on. So make sure you're using this class time to get your homework done, or as much of it as you can. Yes. As long as it doesn't distract you. Okay, you may get your phones, get started. I'll get the assignment enabled.